Hey guys, so today we're going to do chapter 10 part 1. It's going to be a pretty quick video and I hope you enjoy it. So we don't really need to write anything down until slide 6. This is just talking about different bonding models that we've used through the years. Today we're going to be focusing on one bonding model and also for the next few classes. The bonding model that we focus on is Lewis theory. Okay, so Lewis theory is when we have valence electrons of main group elements that are represented as dots surrounding the symbol of the element. I generally call these Lewis dot structures. Okay, again, remember that the main group elements, those are the ones with A's at the top of your periodic table. So you will need to look at your periodic table for this specific lesson and the rest of this chapter. So please make sure you have it out and available. Okay, so for Lewis theory, again, we're looking at the dots. Also remember, you can tell the easiest way to tell valence electrons is by the letter A, that number that's with A. So they do fill singly, so I like to kind of just go around clockwise. You will see when I do another element. So the element that's on the next slide is oxygen. We know that oxygen has 6 valence electrons because it is in 6A. So this is how I would do oxygen. 1, 2, 3, 4, 5, 6. And I know that picture is the same, but it's easier to see when you see the process of it. Okay, so they fill dots singly first, or individually is really a better word, and then they pair, just like Hund's rule. Okay, and a symbol has 4 sides, so they just go around single and then they pair. All right, here's an example of the second row, all of the second row elements. Okay, so on the next slide, we're going to see phosphorus. I would draw phosphorus with the dots at the top, so 1, 2, 3, 4, 5. If you are at home during mastering, you probably need to message me because mastering is pretty finicky when you're doing these. Okay, helium is special. Remember that helium only has 2 valence electrons even though it's a noble gas and in 8A. That is because it only has the S sublevel, and so it only has 2 total electrons. This is the only time what we call a duet when we're doing an element, that they are single, or that they're paired in just having 2 for that element. All right, we've already done phosphorus. So magnesium, again, I don't care if you do it on top and on the side. I do try to get them as far apart as possible, so this is what my magnesium looks like. And to be honest, if I were doing oxygen, it would look like this, just because when we start bonding them later, it's going to be easier to do this way. Also, they do magnesium like that as well. All right, so we've talked about chemical bonds before when we had chapter 5, we did naming. Okay, just recall that bonds involve either the transfer or the sharing of electrons, and the whole goal is that they get a stable electron configuration. If you recall, the noble gases are stable because they have 8 valence electrons. They're full, they've got that full shell. Okay, so everything is trying to get to 8. That's called the octet rule. It's on the next slide. So electrons are transferred in ionic bonds, and they are shared in covalent bonds. Today we're doing ionic. Next class we're going to do covalent. So the octet rule, again, it is just that every atom wants to have 8 valence electrons. Now there are a couple exceptions, the biggest one being hydrogen and helium. Again, we'll get to those when we do the covalent bonding next class. So they will either transfer or share electrons so that they have 8 total in their outside shell. Octet rule. Okay, recall ionic bonds are metals and nonmetals. Remember that the metal is the cation, that's the positive charge, and the nonmetal is the anion. Okay, and it is always from the metal to the nonmetal. That's how the electrons are transferred, from the metal to the nonmetal. So remember, metals don't want their extra valence electrons, they give them away. They give them to the nonmetal that wants them. All right, so here is an example. It's really easier to see when you see it move. So what happens is potassium has 1 valence electron, chlorine has 7. Potassium doesn't want its electron, so it gives it to chlorine. So now potassium has none. When potassium has none, it has a +1 charge. And then when chlorine has 8, it's got a -1 charge. Okay. If you want to show the movement, that's fine. But this is the answer. Where they've already moved, we're done. I will tell you. So the metal in an ionic bond will always get 0 dots. And then you do need its charge. Always. Metal gets 0 dots, put its charge. The nonmetal, hopefully you can see, will get 8 dots. And it'll have a charge, and it'll have brackets. So brackets are like right-angled parentheses. You have to bracket it in if it has a charge and dots, always. Okay, and we'll see that a little bit later in the chapter as well. But this is how you always draw them. You do not have to show that them moving, although they do move. They always, the metal gets 0, the nonmetal gets 8, both get charges, put brackets on the nonmetal. All right, it's showing the same thing there. So magnesium starts with 2. It gives both of its electrons to oxygen. So oxygen has 8, magnesium has none. Put their charges. Y'all, these are just the normal charges from the periodic table that we wrote at the beginning of the semester. All right. When there is more than one, you do have to draw both. And y'all, some of you, so the book says, and mastering, it'll tell you to write the formula for sodium and sulfur. So if you remember when we were doing chapter 5, remember these values, they come down and the plus and minus go away. So that's how we get our formula Na2S. It is because you need 2 sodiums to cancel out the 1 sulfur. And you can see that because here this sodium gives 1 electron, and then you need another sodium to give the second electron to have 8. So you do have to draw all of the pieces in the formula. Okay. Please just make sure you draw everything that's shown in the formula. All right, we've already seen MgO. Let's do sodium bromide. So sodium has a +1 charge. It is a metal, no dots. Bromine is a nonmetal. In fact, it's a halogen. So it had 7. It gets 1 more to make 8. And then you put its charge. Y'all, you do have to put a number for the charge if it is more than 1. It's just like in math, we don't write ones unless you have to. Like, unless you don't have to. You can, but you normally don't. So here's what I was talking about. It wants you to predict the chemical formula. This is the wording that'll be on mastering. This is where we just look at the charges. You bring down the numbers. Again, the plus and minus go away, and we get CaCl2. You can also see it, here I'll write this over to the side, with the valence electrons, because you need 2 chlorines to get those 2 dots from calcium, those 2 valence electrons. Okay, let's do another one. We've got magnesium. We've got nitrogen. So the formula is Mg3N2. Okay, if you have questions, please reach out. And that is it for today. Y'all have a great day.